solving the problem of the lunar regolith. I'm Tonya Hall, and joining me is Dr. Philip Metzger, planetary scientist at the University of Central Florida and co founder of the Kennedy Space Center, SwampWorks. Welcome, Dr. Metzger.
Hi, Tanya. Glad to be here.
Give us a quick summary of your work as it relates to NASA and the exploration of our solar system.
All right, I'm a planetary scientist, but I like to say I'm an applied or an economic planetary scientist because I try to work on applications that utilize resources in space for activities of humanity. I've worked on uh, the blast effects of landing rockets on the moon or Mars, and I've worked on how to do construction, like how to build landing pads, and extraction of resources, like, for example, mining ice from the lunar regolith.
Humans have some pretty big plans for colonizing Earth's nearest neighbor, our moon. We want to build habitations, conduct scientific study, perhaps build mining operations. But there's one big challenge that we have to address related to the nature of the lunar regolith or soil. What's the background on that?
Yeah, so I assume you're talking about the dust, trying to manage the challenges of the lunar dust. Yeah, that is a big challenge. In fact, I think the lessons we learned from the Apollo program is that dust is the biggest challenge. And I would argue, I would start out by telling you about the geology that makes the moon so problematic with dust. Here on the Earth, we have an atmosphere which has rain, and so we have rivers and lakes, and that over geologic timescales tends to wash the dust particles out of the environment. But you don't have that on the moon. Instead, we have micrometeoroids constantly bombarding this airless surface of the moon, busting up the particles to make them finer and finer and finer. So it could be about 20% of the mass of the soil. If anywhere you go, if you grab a handful, 20% of that material is ultra fine dust. And it's super jagged, sharp. It's very bad for your lungs. It's bad for machinery. It gets into the joints of robots and it gums things up. It gets into the seals of spacesuits and causes them to leak. So we've got to develop a program of managing and mitigating that dust. I also like to quote from Jack Schmidt. I've heard him say this several times. He says, what we need is a multi-tiered engineering approach. There's no one solution to the dust, but if we have like a full court press in terms of basketball, we got to fight dust every step of the way down the court. And by doing that, we can manage it.
How does the lunar dust affect the human body physiologically?
Oh, that's a great question. Like I mentioned, Earth is not the same as the moon. And so our bodies are adapted to this environment, which doesn't have all of this huge amount of dust and doesn't have these sharp angular particles everywhere. So our body is not adapted to handling the environment of the moon. Um, on our bodies, when you breathe in, the air has to weave around through the I don't know, I'm not a medical doctor, but in around near your sinuses. And as the air goes around these corners, it's like a shop vac. The angular momentum of the particles fling them to the outside where they stick on the wet inner surfaces, and you end up sneezing and the mucus comes out and it's dark because it's got all the dust. And so it keeps the dust from getting deep down into the bottoms of your lungs. But on the moon, where there's just so much dust, it overwhelms your defenses. The dust is a lot finer than what you'll find on the Earth. And so the dust will follow the airflow more precisely, and it'll make its way all the way down, get into the bottoms of your lungs. And it can build up in your lungs. It's very sharp and it cuts the tissues. Over time, it can cause cancer. And it can cause, we believe, it can cause a disease similar to silicosis, which is what sandblasters used to get here on the Earth until we realized that we need to stop doing all the sandblasting without protection. So, So because of that, we need to find ways to keep the dust from getting into your lungs. It's also an irritant to your skin. It can dry out the pores. It can irritate your eyes. Um, so those are the general challenges.
Then what does the dust do to machines, equipment, and robots?
Yeah, so it works its way into joints. Like if you've got an axle with a wheel turning, constantly turning, because it constantly turns an infinite number of times, you can't put a boot over that joint. And because you can't boot it, you just can't stop the dust from getting to the sliding surface, and the dust works its way in and it creates friction, and so over time it wears out the joint, and it increases the friction until eventually the machines are overworking and they jam up and they can't function anymore. So the way you solve that is through a number of techniques. You try to avoid rotating joints so that you can boot the joint. You try to make your joint have technologies inside to make the dust go out instead of go in. But these are all things that are currently being researched. There's a lot of work that needs to be done to improve this.
Apollo 12 astronauts visited our Surveyor 3 spacecraft. They were surprised to see it was a tan color instead of white. Why was it tan?
That's a really interesting topic. So the person who said to Houston, the astronaut who pointed it out was Alan Bean. And I was blessed to have a conversation with Alan about this. And so we asked him, Alan, as you were walking up to the Surveyor, you radioed to Houston, what color is the spacecraft supposed to be? And they said, white. Why do you ask? And you said, because it's tan. And Alan said, "Well, he's an artist. He was an artist after the Apollo program until his death. He focused on painting, and he said, well, I think because I'm an artist, I just notice colors more." But we called him up and had that conversation because we were trying to understand when you land a rocket on the moon, how does the rocket exhaust blow the dust, and not just dust, but sand and gravel and rocks. And so we wanted to understand, was the landing of the Apollo 160 meters away, was that what blew the dust all over the Surveyor? And so we were trying to get all the information we could, and we talked to Alan about it. And it turns out that is not what caused the Surveyor to be tan. The tan that was on the Surveyor, it actually was lunar dust, but it didn't come from the blowing of the Apollo landing. It turns out the Surveyor got itself all dusty during its own landing because it bounced a couple of times before the engine shut off. So it was a non-standard landing. It shot dust all over itself. But when the Apollo 12 landed nearby, it did spray dust at a super high velocity, at thousands of meters per second velocity. But the dust from the Apollo landing actually sandblasted the Surveyor clean on one side. So the other side of the Surveyor was actually more tan than the side that faced the Apollo. But we were analyzing all those results. Alan and Pete Conrad cut pieces off from the Surveyor, brought them back to Earth. I had those in my laboratory for a few years, and we analyzed it. We counted all the sand grains that were penetrated in through the paint of the Surveyor. We counted how many per square centimeter. It was like 100 sand grains per square centimeter, in addition to trillions of dust particles all over the surface. So we quantified it. We tried to understand what were the processes of the sand damaging the Surveyor.
How is NASA addressing this challenge? And is there room for private sector businesses like maybe entrepreneurs or investors to contribute?
Well, yeah, NASA is doing a lot of work to understand the sandblasting effects and all of the dust effects, in order to learn how to work and operate long-term on the moon. I should mention that during the Apollo program, they typically only had about 3 EVAs. An EVA is an extravehicular activity. That's where they put on their spacesuits, depressurize the cabin of the lunar module, and then go outside and walk around. So they only did 3. Um, but every time they came back in, their spacesuit was leaking worse than the last time. And so even if they had it in their schedule to do 4 EVAs, they wouldn't have been allowed to because the spacesuit leaks were too bad after 3. So that tells us if you want to live and work long term on the moon, we're going to have to solve the dust problem. We can't be limited to 3 spacewalks and then you're done. Because of this, NASA is investing research into managing the dust. We're investing a lot of research into the sandblasting problem. And so at the university, I'm getting grants from NASA to do tech development and to do physics research, um, as are my colleagues. Um, and then you asked about industry, and absolutely, yes, there's a big role for industry. I'm working directly with several space companies, including we have some contracts with Masten Space Systems to study how does the rocket directly blow the soil. We're doing experiments into that. NASA gave us a grant recently to build an instrument and to put it on a Masten Space Systems lander. And this instrument shoots laser beams down into the dust and it measures the blowing of the dust during lunar landings. So that was kind of cool. That was quite an experience.
Dr. Philip Metzger, planetary scientist at the Florida Space Institute of the University of Central Florida and winner of the Silver Snoopy Award. Thanks for joining us, Philip. If somebody wants to connect with you, maybe they want to find out more about this opportunity or the work that you're doing, how can they do that?
I think the easiest way is actually through Twitter at Dr. Phil Till.
All right. Love it. Thanks, Philip.
My pleasure.
And find more of my interviews right here on YouTube, iTunes, and Spotify, or at tonyahall.net. Thanks for watching.